Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over lesson 3.1 of our Accuplacer prep series for arithmetic, focusing on operations on fractions, namely how to add and subtract fractions. Alright, before we get started with some examples, let's go over the steps or strategy for how to add and subtract fractions. So number one, you want to ensure that all the fractions are written in the same form. Preferably, express the fractions as proper or improper fractions. You can add and subtract fractions if you have a combination of whole numbers and mixed numbers, but expressing them as proper and improper fractions is very beneficial, especially in higher level math. Number two, you want to ensure that the denominators of the fractions are the same. If they're not, then you have to find the LCD of all the denominators, then convert all the fractions into equivalent fractions with their denominators equal to that LCD value. Now, after step 2, you should have fractions in the same form with their denominators the same. Step 3, you add or subtract the numerators depending on the operation, but you keep the denominators the same. You don't add or subtract the denominators. Where applicable, you reduce and express the final result as mixed numbers. Okay, so these are the steps we're going to be applying to the following examples. Now, on the Accuplacer exam, you're not going to be allowed to use a calculator, expected to do everything by hand. Only for certain problems where you might have a pop-up calculator, but most of the components of the arithmetic part, you're not allowed to use calculators. So we're not going to be using a calculator for these examples. So the instructions are to find the following without a calculator. And then we are to express the final result as reduced fractions in mixed numbers where applicable. So if we have a situation where we can reduce, we reduce. If we can express the answer as a mixed number, we'll go ahead and do that after the reduction. So question number 1, what if we were to find the sum of 2/7 and 4/7? Now, step 1 require that the fractions are in the same form, either proper or improper fractions. So here we have two proper fractions, so that's good. Now, the denominators is our next focus. You notice that the denominators are identical, which is perfect. So now if we have identical denominators, to proceed, we'll just simply add the numerators. And what do we do with the denominator? We keep the denominators the same. Okay? So when we add 2 plus 4, we have 6. 6 divided by 7 is your final answer. Okay, this is a proper fraction in reduced form, and that's all we have to do for this particular problem. Alright, let's consider question number 2. What if we were to find the difference between 2/3 and 1 and 1/3? Okay, now we have a mixed number and a proper fraction. We need to convert the mixed number into an improper fraction before we can combine them. Okay, so to do that, we'll just bring down 2/3 minus. Now, how do we convert 1 1/3 to an improper fraction? You just multiply the denominator by the whole number and you add the numerator, right? 3 times 1 is 3, plus 1 is 4, so we have 4/3. Okay, now we have two fractions. We have the denominators are identical, which is excellent. So we can go ahead and combine these two. We have 2 minus 4. Find the difference in the numerator, and you keep the denominator the same. Okay, 2 minus 4. The signs are different. You subtract, and you keep the sign of the bigger one. The bigger number is 4, and it's negative, so our result is going to be negative upon subtraction. So answer for question number 2 is negative 2/3. All right, let's take a look at question number 3. Now, what if we have 3 fractions? What if we have 1/4 plus 3/4 minus 1 1/4? Okay, so we have 2 fractions and a mixed number. So how can we proceed? Of course, we need to change this mixed number into an improper fraction. Okay, just like we did in the previous one. Multiply the denominator by the whole number, and then you add the results to your numerator. So that will give us, bring down 1/4 plus 3/4 minus 1 times 4 is 4 plus 1 is 5. 5/4. Now the nice thing about these 3 fractions that we have is that their denominators are identical. Okay? So we're going to combine all the denominators into one. The denominator stays the same. And then we'll go ahead and compute the sum of these two numbers, minus 5. Now, using your order of operations, please excuse my dear Aunt Sally. Let me write it again, so I didn't write it properly. So, please excuse my dear Aunt Sally. So, addition and subtraction are in the same hierarchy, but you execute it from left to right. Okay? In that order. So, following the order of operations, we're going to combine the first two first. So, 1 plus 3 is 4 minus 5 divided by 4. So what's 4 minus 5 is going to be negative 1, since the bigger is negative, and these two numbers have different signs. So when you're combining numbers with different signs, you subtract and keep the sign of the bigger number. So you can see why our answer is negative 1/4. Okay, let's move on to question number 4. Now we're going to be dealing with a scenario where the denominators are not identical. Okay, so what if we want to find the sum of 2/5 and 1/3? Now, since the denominators are different, we have to find the LCD. Okay, so we need to find the LCD of 5 and 3. Now, one nice neat little shortcut about finding the LCD of prime numbers is that, when finding the LCD, is that if you have two prime numbers, the LCD is simply the product of the numbers. Okay? So since 5 and 3 are prime, the LCD of 5 and 3 is simply the product of these two prime numbers, 5 times 3, which is 15. Now, why are we looking for the LCD? Well, because we want to make the denominators equal to the LCD. We want to convert these fractions into equivalent fractions where their denominators are both 15. Okay, so let's start with the first one, 2/5. What do I multiply the denominator by to make it 15? Multiplied by 3. In order not to change the fraction, I have to multiply the numerator by exactly the same number. So what I'm doing in essence is multiplying the entire fraction by 1, the multiplicative identity, which does not alter the result upon multiplication. It's going to look different, but it's the same value as 2/5. Now, how about 1/3? We need the denominator to be 15. So I need to multiply by 5, top and bottom. All right, so the equivalent fractions that we're going to be expressing these two as, the first one will be 6 over 15, and the other is 5 over 15. These fractions are equivalent to the other ones, but we just changed the look so that the denominators will be the same, namely the LCD. Okay? Alright, now let's go ahead and move on to the next step. If the denominators are the same, you add the numerator and keep the denominator the same. Now what's 6 plus 5? That's 11 over 15. That is the answer to question number 4. Okay, let's move on to number 5. How about subtracting two fractions with different denominators? So consider this: 7 over 15 minus 3 over 12. The denominators are different, so since the denominators are different, we have to find the LCD. Okay, so we have to find the LCD of 15 and 12. These are not prime numbers, they're composites, so more work needs to be done in this case. Now what we have to do is express these two as a product of primes. Then we'll use our chart method to determine what the LCD is. Alright, let's write 15 as a product of prime. We're going to use our factor tree to decompose it. Does 3 go into 15? Absolutely. If you add the digits, you have a multiple of 3. 3 goes into 15 5 times, so 15 can be written as 3 times 5. How about 12? Using our factor tree, 3 goes into 12 how many times? 3 goes into 12 4 times. 4 is composite. We can decompose it further into 2 and 2. So 12 is 3 times 2 times 2 expressed as a product of primes. Now we're going to create our LCD chart and use it to find the LCD of the two numbers. Okay, so all we'll do is put the numbers to the left side, and then we're going to organize their factors, the product of primes. But there's a strategy that we'll use in organizing the factors. Now this is the rule: you cannot have different factors in the same column. Okay, only identical prime factors can be in the same column. That's the rule. Okay, so let's start with 15. We have two factors there. None of the columns are occupied, so you can place 3 and 5 wherever you want. Now, since we've populated the first row, this first column can only take 3. This second column can only take 5. Any other factor will end up in another column. Okay? Now we're going to put in the prime factor decomposition of 12 in here. We have 3, so we need to put a 3 here. And then we have 2 and then another 2. This is a 5 column, so we can't put a 2 underneath since we have a mismatch. So we have a place a 2 here and then place another 2 here. And that's it. Okay? So this chart is pretty cool. It tells us the GCF of the two numbers, and it also tells us the LCD. The intersection is the GCF, so the GCF is 3. But the union is the LCD. So just bring this down: 3 times 5 times 2 times 2. And that's your LCD. Okay? So we can do this. 5 times 2 is 10. 10 times 6 is 60. So that's your LCD. Okay? So the LCD of 15 and 12 is 60. So we need to express these two fractions as equivalent fractions where their denominator is equal to 60. So let's start with the first one, 7 over 15. We can use this chart to assist us in determining what number can be multiplied by the numerator and denominator to get the LCD. 15 is 3 and 5. You see these two numbers here? That's what's left in order to make it 60. So what do? We multiply them by 2 times 2, which is 4, on the top and on the bottom. Subtract 3 over 12. Now I want 12 to become 60. So look at this. We have 3, 2, and a 2, right? So what's left to make 12 60? We have 3, 2, 2. We are left, we need 5 more. Okay, we need to multiply it by 5. 3 times 2 times 2 is 12. 12 times 5 is 60. So we're going to just multiply by 5. 5. Now this first fraction reduces to 28 over 60. Minus 3 times 5 is 15 over 60. Now we have identical denominators, which is excellent. We can now express the denominators as 1, just the same as this original denominators here, and we subtract the numerator. 28 minus 15 is 13. So we have 13 divided by 60. This cannot be reduced, and it's a proper fraction, so that is our final result. Alright, let's go ahead and try one more example. Question number 6. Now what if we have 2 1/4 plus 3 2/3 minus 4 3/10? Now we have 3 mixed numbers. Okay, so we want to convert these into improper fraction. That will make our lives much easier. So if we convert these 3 into improper fractions, what do we get? The first one, 4 times 2 plus 1, will give us 9 over 4. Plus the second one, 3 times 3, 9 plus 2, 11 over 3. The last one, 10 times 4, 40 plus 3, 43 over 10. So now we have 3 improper fractions where the denominators are different. So since the denominators are different, we need to find the LCD of the 3 denominator values. So we'll find the LCD of 4, 3, and 10. Okay? We have only one prime number here, but the rest are composites, so we need to use our LCD chart. So break down 4 into a product of primes. 4 is 2 times 2. 3 is just a prime number, so we just leave it alone. 10 is a composite, which can be broken down into 5 and 5 times 2. So can we find the LCD now? Yes, let's go ahead and use our LCD chart. Alright, so we are going to have 3 entries in this particular case. Alright, we're going to have 4, we're going to have 3, and we're going to have 10. Okay, now let's see what the deal is with 4. 4 can be decomposed into 2 times 2. So we have 2 columns that can only be filled up with a 2, and the other one can only be filled up with a 2. The next denominator is 3. 3 is prime, so we can put the 3 here since it doesn't match any of these 2 factors from 4. And then the last denominator was 10, and the prime factor decomposition of 10 is 2 times 5. We can't place 5 here or here because it doesn't match. Bam, there you go. Okay, now let's go ahead and determine what the LCD is. You just find a union of the 3 rows. So you have 2, times 2 times 3 times 5. Okay? So we can multiply 2 by 5, that's 10. 10 times 6, 60 again. So that's the LCD. Okay, so now we need to convert these four improper fractions into improper fractions where their denominators are equal to 60. For 4, we have 3 and 5 remaining, which is 15. So times this by 15, top and bottom. 11 over 3, we want to convert it into an equivalent fraction where the denominator is 60. So 3 times what is 60? 3 times 20 yields 60. Okay. And then how about the last one? The last one is 43 over 10. So we need to multiply the numerator and denominator by 6 because we know that 10 times 6 is 60. Okay, let's multiply. 9 times 15 is 90 plus 45, which is 135. 4 times 15 is 60, plus 11 times 20 is 200 plus 20, which is 220 over 60. 43 times 6 is 240 plus 18, which is 258 over 60. Now the denominators are identical. We can now unite all the denominators into one, namely the LCD, and focus our attention on the numerator. Alrighty, so now we have in the numerator 135 plus 220 minus 258. In the order of operations, adding and subtracting are on the same hierarchy, but we execute them from left to right. Okay, so we just add and subtract from left to right. So we're going to do the first two first. 135 plus 220. 5 plus 0 is 5. 3 plus 2 is 5. 1 plus 3. 1 plus 2 is 3. So we have 355 minus 258. Now when you're subtracting, if you don't want to make mistakes, you can just align them vertically and then you just subtract, okay? So we have 355 minus 258. This is too small, you borrow 1, make that a 4. 15 minus 8 is 7. 4 minus 5, that's too small, you borrow 1, make this a 2. 14 minus 5 is 9. So our answer is going to be 97 divided by 60. This is an improper fraction. It can be expressed as a mixed number. 60 goes into 97 exactly once. And then when we subtract 60 from 97, we are left with 37 over 60. Okay? So the way you do this, we already went over improper fractions slash mixed number conversion in our previous tutorial. I think it was 1, 2, or 1, 1. You have 97 and 60. So 60 goes there just once. 1 times, and then you subtract this. You get 37 as your remainder. Okay? So that's how we have one whole number, 37 over 60, as our final result. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this presentation helpful in your preparation for the upcoming Accuplacer exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments on what we went over, just place your comments in the comment section below. Even your questions, and we'll be more than glad to assist you. Don't forget to subscribe to our channel. We update videos to our YouTube page on a regular basis, so do subscribe so you can get updates to those videos. Don't forget to visit our website at mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.